Hello everyone and welcome to this video on geometry. In this video we will understand what are the various angles which are associated with a geometrical shape. We'll see what is a polygon, we'll understand what is a regular polygon and discuss certain properties of it. Then we'll discuss in detail about one of the most important figures in this geometry, that is triangle. We'll discuss some general rules which are associated with the triangle. We'll understand what is the rules of similarity and congruency of triangles. We'll understand what is median, what is altitude, inradius and circumradius. Then we'll discuss in detail about three important triangles, that is equilateral, isosceles and right angle triangle. So let us begin. Angles. So what is an acute angle? Any angle which is greater than 0 degree but less than 90 degree is an acute angle. So in this figure you can see this angle is an acute angle. Right angle is simply 90 degree. So in this figure you can see this angle is a right angle. Obtuse angle, any angle which is greater than 90 degree but less than 180 degree is an obtuse angle. So in this figure this angle is an obtuse angle. So what is a reflex angle? Angle which is greater than 180 degree but less than 360 degree is a reflex angle. And this figure, this angle is reflex angle which is clearly greater than 180 degree and less than 360 degree. Let us now understand what are complementary and supplementary angles. Let us consider this figure. Let this angle be A, this angle be B, and here we have a 90 degree. As we know, sum of all the angles in a triangle is 180 degree. Since one of the angle is 90 degree, that means sum of the other two angles will also be 90 degree. So angle A plus angle B is 90 degree. So for any pair of angles for which their sum is equal to 90 degree, they form a complementary angle. They form a pair of complementary angles. So angle A is complementary of angle B and angle B is complementary pair of angle A. So what is a supplementary angle? Let us just extend one of the sides of the triangle and name this angle as C. Now clearly angle A plus angle C will be 180 degree. So for any two pair of angle whose sum is equal to 180 degree, they form a supplementary pair. So angle A is supplementary of angle C and angle C is supplementary of angle A. So this is all about complementary and supplementary angle. Let us now move ahead. Now we will discuss one by one each of these angles, interior angles, co-interior angles, exterior angles and so on. Let us consider this figure. I'll just join these 2 points. Now focus on this part of the figure, the one which I have highlighted with red. Okay. So let us start with interior angle. What is an interior angle? Interior angle is the angle formed between two adjacent sides of a rectilinear figure. A rectilinear means straight. So since this figure is made up of straight lines, hence it is a rectilinear figure. So this angle, all these 4 angles will be called as interior angles. So what is exterior angle? If I extend the sides of this rectilinear figure, I have extended each of the sides of this rectilinear figure, the angle formed by the extended side with one of the sides of the figure is called as exterior angle. So this angle, let me use a different pen. So this angle will be an exterior angle. Even this angle will be an exterior angle. On the similar lines, this angle and this angle will also be called as exterior angles. Now this angle will not be an exterior angle because this angle is formed between two extended part of the figure. For exterior angle, one portion should be the extended part and the other portion should be the part of the figure. Okay, then only it will be called an exterior angle. So what is a co-interior angle? Angle lying on the same side of the transversal is called as co-interior angle. So since this is the transversal and these are the two parallel lines, this angle and this angle are called as co-interior angles. Okay. Let us now understand what is alternate angle. For alternate angle, always remember to spot Z, because an alternate angle is always formed between two pair of parallel lines cut by a transversal. So in this case, this angle and this angle will be an alternate angle. Okay. Similarly, we have a Z over here also. So this angle and this angle will be alternate angles. Let me name these angles: 1, 2, 3, 4, 5, 6, 7 and 8. So angle 3 and 6 will form a pair of alternate angles. Then angle 4 and angle 5 will also form a pair of alternate angles. Okay. Let us now move ahead to vertically opposite angles. Vertically opposite angles are formed when any two lines intersect each other. So these two angles will be called vertically opposite angle. So from this figure, angle 3 and 2 are vertically opposite. Then angle 1 and 4 also are vertically opposite. Similarly, 5 and 8 and 6 and 7 are also vertically opposite angles. Corresponding angles are formed when two parallel lines are cut by a transversal. The angles which are formed at the corner are called as corresponding angles. So in this case, 1 and 5 will be corresponding angles, will form a pair of corresponding angles. Similarly, 2 and 6 will form a pair of corresponding angles. Okay, I hope you are able to understand the various types of angles which are associated with a geometrical figure. Let us now move ahead. Polygon. So what is a polygon? Any plane figure which is formed by a series of closed rectilinear lines is called a polygon. For example, a triangle, it is a polygon. Then a square or a rectangle, it is a polygon. A hexagon, it is a polygon. So all these figures are made with the help of a straight line, and these are all closed figures. So these can be classified under polygon. Poly means many and gon means angle. So there are many angles in the figure. Now what is a regular polygon? A polygon with all the sides and angles equal is called a regular polygon. So a square, all the angles are 90 degrees, all the sides are equal, will be a regular polygon. An equilateral triangle will also be a regular polygon. Let us now see some properties associated with a regular polygon. Sum of all the interior angles of a regular polygon is given by 180 into n minus 2, where n is the number of sides. So for a square, the number of side is 4. Let us substitute in the formula. We'll get 180 into 4 minus 2 will be 360. As we know, each of these angles is 90 degree. So sum of each of the interior angles will be 360 degree. And from the formula also we are getting the same answer. For a triangle, the number of side n is 3. If you substitute in this formula, we'll get 180 into 3 minus 1, which will be 180 degree. As we know, sum of all the interior angles in a triangle is 180 degree, which we are getting the same answer from the formula as well. So each interior angle will be given by sum of all the interior angles divided by number of sides. So in this way you can find each interior angle of a regular polygon. Then sum of all the exterior angles of a regular polygon will always be equal to 360 degrees. It is important you note down this point. Then each exterior angle of a regular polygon will be given by 360 degree divided by number of sides. Another important property is for a regular polygon, sum of each interior angle and each exterior angle is always equal to 180 degree. Okay. Let us now see how do we apply these formulas. Find the number of sides, interior angle and exterior angle of a regular polygon whose sum of the interior angle is 720 degrees. So sum of all the interior angle is given to be as 720 degrees. If we substitute in the above formula, we will get 720 is equal to 180 into n minus 2. So 180 ones up, it will be 4s up. So number of sides will be equal to 6. Hence it is a hexagon. Okay. So the number of sides is 6. Now each interior angle will be given by sum upon number of sides. Sum of all interior angles is given to be 720 divided by number of sides, which is 6. So 6 into 12. So each interior angle will be 120 degrees. Now each exterior angle will be given by 360 upon number of sides. So 360 divided by 6 will give me 60 degrees. So each exterior angle in case of a hexagon will be 60 degrees. Now if you add these two, you are going to get 180 degrees. So sum of each interior angle and each exterior angle will be 180 degrees. Okay, let us now move ahead. What are the formulas for area of a regular polygon? There are two formulas. Number one, area is given by ns square upon 4 into tan of 180 upon n. So let us take an example of a square. In square, the number of side is 4. So here n is the number of side and s is the length of the side. Remember, this formula is applicable only for a regular polygon. So in case of a square, we know the formula for area is s square. Let us see how do we arrive using this formula. So if we substitute n equal to 4, we will get 4 into s square upon 4 into tan of 180 by 4. So this 4 will cancel out. 180 by 4 will be 45. Tan 45 is 1. We will ultimately get s square. This formula you can use for equilateral triangle also. For equilateral triangle, we know number of sides is 3 and the formula is given by root 3 by 4 s square, which will be length of the side. Let us see how do we arrive at this formula with the help of this equation. So if we substitute n equal to 3 in this formula, we get 3 s square upon 4 into tan of 180 upon 3. So tan 180 upon 3 will be tan 60. Tan 60 is nothing but root 3. So we'll get 3 s square upon 4 into root 3. So if we just cancel out one of the root 3, we'll get root 3 by 4 s square, which is the same formula. Okay. So this is one of the formula for finding the area of a regular polygon. Another formula is product of semi-perimeter and in radius. We will see how to apply this formula in specific cases ahead. Let us now move ahead. The formula for number of diagonals of a regular polygon is given by this: n into n minus 3 by 2. I have explained this concept in detail in a video on permutation and combination. You can watch that out. So in case of a square, the number of diagonals, as we know, is 2. So if the number of sides is 4. If we substitute n equal to 4, we will get 4 into 4 minus 3, that will be 1 upon 2. So we will get 2. In case of a hexagon, the number of diagonal will be 1, 2, 3, then 4, 5, 6, 7, then this will be 8 and this will be 9. So there are 9 diagonals. If we use the formula, we will have to substitute n equal to 6. We'll get 6 into 6 minus 3, which will be 3, divided by 2. So this will be 3 into 3, which is again coming out to be 9, as we have counted it manually. So these were the sum of the properties of a regular polygon which will be useful. Let us now move ahead. Triangles. Let us first of all understand what are the different types of triangles and what are their properties. Acute angle triangle. In acute angle triangle, all the angles will be less than 90 degrees. So each of these angles will be less than 90 degrees. In a right angle triangle, exactly one angle will be equal to 90 degrees. In an obtuse angle triangle, exactly one angle will be greater than 90 degrees. Okay. Then in an equilateral triangle, length of all the three sides will be equal and each of the three angles will also be equal and its value will be 60 degrees. If the length of any two sides are equal, then such a triangle will be called an isosceles triangle. Also, the angle formed by the two equal sides with the third side will also be equal. So these two angles will also be equal. Alright, we'll discuss in detail the properties of these three triangles: the right angle triangle, equilateral triangle, and isosceles triangle. Let us now move ahead. We'll discuss some general information related to a triangle. Consider this triangle. I have extended the sides of this triangle. These are the extended portion which you can see. Let us now name this figure. Let this angle be A. Side opposite to this angle be small a. This exterior angle be alpha. Okay. Let this angle be B. Side opposite to this angle be small b, and this exterior angle be beta. Then let this angle be C. Side opposite to this angle be small c, and this external angle be gamma. Now the very first property states that sum of the length of any two sides is always greater than length of the third side. That means A plus B will be greater than C, or A plus C will be greater than B, and C plus B will be greater than A. So this condition for any triangle will always be satisfied. Sum of any two sides will always be greater than the length of the third side. On the similar lines, difference between the length of any two sides will always be less than the length of the third side. That means if A minus C will always be less than B, and A minus B will always be less than C, and B minus C will always be less than A. So the difference between length of any two sides will always be less than the length of the third side. Let's move ahead. Any exterior angle will always be equal to sum of the two remote interior angles. So here we have an exterior angle alpha. So value of alpha will be equal to sum of two remote interior angles. So the remote interior angles are A and B. So alpha will be equal to A plus B. Similarly, beta will be equal to B plus C, and gamma will be equal to A plus C. Let us see now what is the sine rule. It states that the ratio of the side and sine of angle opposite to it will always be equal. So A upon sine of the angle opposite to this side, which will be sine A, this will be equal to, let's say, B upon sine of the angle opposite to it, which will be sine B. So B upon sine B. This will be equal to C upon sine C, and this will be equal to 2 times R, where R is nothing but circumradius. We will see what is this circumradius. Let us now move ahead and see what is the cosine rule. The formula for cosine rule is A square will be equal to B square plus C square minus 2BC cos A. Similarly, B square will be equal to A square plus C square minus 2AC cos B, and C square will be equal to A square plus B square minus 2AB cos C. So what does this sine rule and cosine rule helps us to do? It helps us to relate the side with the angle. If you know the sides, you can easily find out the angles. If you know an angle and two sides, you can easily find out the length of third side using the sine rule and the cosine rule. We'll see the formula for area of triangle now. The basic formula of area of triangle, as we know, is area is equal to half base into height. This is the formula that we have been learning since our childhood, so there is no problem in this one. Now, before we move ahead, let us first understand what is this figure. So this is one of the triangle, and the circle which is drawn inside the triangle is called incircle, and the circle which is drawn passing through the vertices of the triangle is the circumcircle. We'll see what is a circumcircle and what is incircle in detail. For now, just understand that a circumcircle always passes through the vertices of the triangle. An incircle is drawn in such a way that all the three sides of the triangle are tangent to it. Okay, so let this be the in radius and let this be the circumradius. Let us name this figure. Let this angle be A, this angle be B, this angle be C, side opposite to A be small a, this will be B, and this will be small c. Okay, now the second formula for area is given by area is equal to half BC sine A. Let us understand the structure of this formula. This is product of the two sides and sine of the included angle. So it is half BC sine A. It can also be written as half AB sine C. And it can also be written as half AC sine B. Then another formula is Heron's formula, which is given by square root of S into S minus A into S minus B into S minus C, where S is the semi-perimeter. So what is semi-perimeter? It is the sum of length of all the sides of the triangle. So semi will be half of it. So this is the value of S. Then the next formula for area of triangle is area is equal to in radius, which is small r, into semi-perimeter. Then another formula for area of triangle is ABC upon 4r, product of all the three sides divided by 4 times r, where r is the circumradius. So these are the 5 formulas which you can use for finding out the area of a triangle. Let us now understand the concept of similarity and congruency of two triangles. So what is similarity? Similarity means similar in shape. If two triangles appear to be similar in shape, they will be similar. Whereas congruency means exactly the same. Means all the three sides of the triangle will be of equal length. All the three angles will also be equal. If this condition is satisfied, then the two triangles are said to be congruent. Now note, two congruent triangles will always be similar, but two similar triangles may not necessarily be congruent. So what are the conditions for proving congruency and similarity? If we are able to prove that two triangles are congruent, then they automatically are similar. Okay, so there are 4 conditions for proving this congruency or the similarity of a triangle. Number 1 is SAS, which is side angle side. If we prove that any two sides of a triangle are equal and the included angle between these two sides are also equal, then it is sufficient to say that the two triangles are congruent as well as similar. Remember, congruency implies similarity, but not vice versa. Second rule for congruency is AAS or ASA. If we are able to prove that any two angles and one of the side is equal, then the triangles are similar. Then the third is side, side, side. That means if we prove that all the three sides of two triangles are equal, then it is sufficient to say that both the triangles are congruent as well as similar. Then the fourth condition is SSA. That means if two sides are equal and the angle opposite to the biggest side is also equal, then we can say the two triangles are congruent. One point to note here for the second condition is that if we prove two angles are equal, then the third angle automatically becomes equal, because sum of the angles in a triangle is 180 degrees. If the two angles are equal, then third angle will automatically become equal. For two similar triangles, the ratio of their proportional sides will be equal to the ratio of their medians, will be equal to the ratio of their heights, will be equal to the ratio of their inradius, will be equal to the ratio of their circumradius. Also, the ratio of their areas will be equal to the ratio of their square of the ratio of their proportional sides. Now, what is a proportional side? Let us understand this. Let us say this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. Let's name the sides. Let's say this is A, B, C, this is P, Q, R. So for proportional side, what we take is, so how do we take the ratio of proportional side? We take the angle, the two equal angle, and write down their ratios. So A upon P, side opposite to the equal angles. So this angle is equal to this angle, side opposite to this angle is A, side opposite to this angle is P. Then next, for these two angles are equal, so side opposite to this angle is C and side opposite to this angle is R. Then for this angle, side opposite to this angle is B and opposite to this angle is Q. So this is how we write the ratios of proportional side. Let us now understand what is a median. If we draw a line from the vertex to the opposite side's midpoint, so since this is the midpoint, these two parts will be equal. Then this line is called as the median. If we draw all the three medians, so this will be so these two parts will be equal, and if we draw the third median, then these two parts will be equal. So the point at which the medians meet is called as the centroid. The centroid divides the triangle in the ratio 2:1. Okay. Let us now understand what is altitude or height of a triangle. If we draw a line from the vertex which is perpendicular to the opposite side, then this line will be called as the altitude or the height of the triangle. So this will also be the altitude, and this line will also be the altitude. These lines will be perpendicular to the sides on which they are drawn. They may not necessarily be at the midpoint. Okay. The point at which the altitudes meet is called as the orthocenter. If we name this triangle, say A, B, C, so O will be the orthocenter. Then sum of the angles formed at the orthocenter and the corresponding vertical angle will always be 180 degree. So in this case, angle BOC plus angle BAC will be equal to 180 degrees. Likewise, you can write for angle AOC plus angle ABC will be equal to 180 degree, and angle AOB plus angle ACB will be equal to 180 degrees. Let us now understand what is a circumcircle. If we draw a perpendicular bisector to each of the sides of the triangle, then the point at which all the three perpendicular bisectors meet will be called as the circumcenter. So now what is a perpendicular bisector? So a line which is both perpendicular as well as divides the side into equal parts is called as perpendicular bisector. So this is perpendicular and it is passing through the midpoint of this side. Similarly, if we draw the perpendicular bisector for this side, so it will be perpendicular and it will bisect the side as well. Similarly, for the third side, it will be perpendicular and it will be bisecting the side as well. So these two portions will be equal. So the point at which all the three perpendicular bisectors meet is called as the circumcenter. With circumcenter as the center, with this point as the center, if you draw a circle, it will pass through all the three vertices of the triangle, and this circle will be called as the circumcircle. The radius of this circle will be called as circumradius. Let us name this triangle, let's say ABC, and call this circumcenter as O. Then the angle subtended by any sides of the triangle at the circumcenter will be twice the corresponding vertical angle. So this is a vertical angle. So if this angle is theta, this angle will be 2 theta. An important point to note here is the circumcenter lies inside the triangle for an acute angle triangle. It lies on the midpoint of the hypotenuse of a right angle triangle and outside the triangle for a obtuse angle triangle. Let us now move ahead and understand what is end radius. If we draw a line which is bisecting each of the angles of the triangle, so this line is bisecting this angle, that means these two angles are equal. If you draw the angle bisector of this angle, so these two angles will be equal. If you draw the angle bisector of the third angle as well, that means these two angles will be equal. So the point at which all the three angle bisectors of the triangle meet is called as the incenter. If we drop a perpendicular from this point to any of the sides of the triangle and take that as the radius and this point as the center and draw a circle, then this circle will be tangential to all the three sides of the triangle and it will be called as the incircle. The radius of such a circle is called as end radius. Now, the angle subtended by any of the sides of a triangle at the incenter will be equal to 90 plus the corresponding vertical angle. So if this triangle is named as ABC and the incenter as P, then angle BPC will be equal to 90 plus the half of corresponding vertical angle, which is half of angle BAC. Okay, let us now move ahead and understand the three important types of triangle: equilateral, isosceles, and right angle triangle one by one. So in an equilateral triangle, as I have said previously, length of all the three sides are equal and each of the angles are also equal and their value is equal to 60 degree. So this is an equilateral triangle. It is a very interesting triangle. If you draw a line from the vertex to the opposite side such that it is perpendicular to it, then this line will bisect the side on which it is drawn, and this line will also be the angle bisector. This happens only in case of an equilateral triangle. You can draw a line from any of the three vertices and the same condition will be repeated. It will bisect the sides and it will bisect the angle. Also, it will be perpendicular to it. It will bisect the angle It will also bisect the sides, and it will be perpendicular. Now since it is bisecting the angle, hence it is the angle bisector. It is perpendicular and bisecting the sides, hence it is a perpendicular bisector as well. And since it is bisecting the sides, it is also the median. So this line is your perpendicular bisector, is your median, and it is your angle bisector as well. So the point at which all the three lines meet will also be your incenter, your centroid, and it will also be your circumcenter. So in case of an equilateral triangle, the incenter, centroid, and the circumcenter is this same point, which is this. Since it is a centroid, it will divide the median in the ratio 2:1. So if h is the height of this triangle, so this will also represent the height because it is perpendicular to it. So if this length is h, then this part, let's say O, let's name this triangle as ABC, and this is O. So this AO part will be equal to 2h by 3, and this part will be equal to OD will be h by 3. So your circumradius will be the distance between your circumcenter and any of the vertices of the triangle. So if you take this vertex, so the length of OA is 2h by 3. So this will be your circumradius. Your in radius is the perpendicular distance from the incenter to any of the sides of the triangle. So this will be h by 3. So now what is h? H, which is the height of your triangle. Let us calculate this. Now each of this angle is 60 degree. So if we consider this triangle ABD, this is your height, this is the, let's say, side of the triangle of length A. So this angle is 60 degree. If we use sine 60, which is equal to opposite upon hypotenuse, so this will be h upon A. So from here we get h is equals to A into sine 60, which is root 3 by 2. So your height is root 3 by 2 times A, where A is the side of the triangle. So your circumradius will now become 2/3 of root 3 by 2 times A, which will give us A by root 3. So this is your circumradius. Your in radius R will be equal to h by 3. Now h is root 3 by 2 times A divided by 3. So we will get A upon 2 root 3. So this will be your in radius. Now if you note that your in radius is exactly half of your circumradius. One last point about the equilateral triangle. The angle subtended by any side of the equilateral triangle at the circumcenter or the incenter or the centroid will always be 120 degree. So how do we arrive at this figure? Now this angle is 60 degree, and since this line is your angle bisector as well, so this angle will be 30 degree. Similarly, this angle will be 30 degree. Now in a triangle, sum of all the angle is 180 degrees. So in this triangle BOC, two of the angles are 30 degrees. So this angle will be 120 degree. Okay. Let us now move ahead to our next triangle, which is the isosceles triangle. As I have explained previously, if length of any two sides are equal, then such a triangle will be an isosceles triangle. So in this figure, the length of these two sides are equal. So this angle made by these two sides with the third side will also be equal. So this angle, if this angle is theta, this angle will also be theta. Now one interesting point regarding isosceles triangle is, if we draw a line from the vertex where the two equal sides meet, such that this line is perpendicular to the third side, then this line will also be your angle bisector. So these two angles will be equal. It will also bisect the side on which it has been drawn. So these two sides will be equal. And since it is perpendicular, so this will also represent your altitude as well as the perpendicular bisector. But this is not the case if you draw a line from any of the other two angles. So if you draw a line which is perpendicular from this angle to this side, it is not going to bisect these two sides, nor it is going to bisect the angles. Okay. Let us call the two equal sides as A and the unequal side as B. So this part will be B by 2 and this part will also be B by 2. So if H is the height of the triangle, we can find H using the Pythagoras theorem. So H square will be equal to A square minus B by 2 the whole square. From this we will get H is equal to square root of, this will become B square by 4. So we will have 4A square minus B square the whole divided by 4. So this is the formula for height of an isosceles triangle. The formula for area will be half base, which is B, into the height, which is H. So the height is this. Let us now understand the formulas related to right angle triangle. So this is a right angle triangle. Let us name this triangle. Say this is A, B and C. So the angle CAB is a right angle. The first formula that should come into your mind in relation to right angle triangle is the Pythagoras theorem. So what is the Pythagoras theorem? It states that the square of the hypotenuse, that is CB, is equal to sum of the square of the two perpendicular sides, which will be AB square plus AC square. So this is our Pythagoras theorem. If we draw a line from the vertex A to the hypotenuse BC such that the point D lies exactly at the midpoint of the hypotenuse BC. So this part will be equal to this part. Now if you remember, in case of a right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. So D will be your circumcenter. So if we take this point as the center and the distance between this point and any of the vertices as the radius, then if you draw a circle, then that circle will be called the circumcircle. So in this case, CD will be the radius of the circumcircle, DB will also be the radius, and AD will also be the radius. So from here we can say that AD is equals to half of the hypotenuse, which is BC. So this is one of the important relation. Remember, this relation will hold true only if D is the midpoint. So what will be now the formula for area of triangle? Area of triangle is nothing but half base into height. So base in this case will be AB and height will be AC. So area will be given by half AB into AC. So this is the formula for area of triangle in case of a right angle triangle. This was the formula for the circumradius, which is half of the hypotenuse, and the formula for inradius will be given by AB plus AC minus BC divided by 2. So these are the important formula related to a right angle triangle: the Pythagoras theorem, the formula for circumradius, the formula for inradius, and the area of triangle. Now let us consider another case where the point D is not at the midpoint, but the line AD is such that it is perpendicular to the side BC. Let us see how this diagram will look like. So let us first of all name this figure. This will be A, B and C. Now if you draw a line from vertex A to the hypotenuse BC such that it is perpendicular to it, So it will somewhat look like this. So this will be perpendicular to BC. Let's name this point as D. Now let us name the sides as well. Side opposite to the angle A, we'll call it as A. So this entire thing will be A. Side opposite to angle C will be called as C. So let us call this side as small c. Similarly, side opposite to angle B will be small b. Let us name this small portion. This portion BD will be P, and this portion CD, let's say it is Q. Okay. So in this triangle also, angle CAB is a right angle triangle. So now as you can see, there are three triangles. Angle ABC, which is a bigger triangle. Then we have a smaller right angle triangle, which is ADC, ADC, and another right angle triangle ADB. All these three triangles are similar to each other. Let us see how. If you consider the first pair of right angle triangle, let's say triangle ABC, which is a bigger triangle, and triangle ADB, which is the next bigger triangle ADB. Remember, since this angle is 90 degree, so this angle will also be 90 degree. So in the bigger triangle, we see that angle CAB is 90 degree, and in the next bigger triangle, angle ADB is also 90 degree. So these two angles are equal. So angle CAB is equal to angle ADB. And both of these angles are equal to 90 degree. Now, if you notice, angle ABC and angle ABD are common to both the triangles. So we can say that angle ABC is equal to angle ABD. Both are common angles. Since two angles are equal, the third angle will also be equal. So the third angle in this case is angle ACB will be equal to angle DAB. So these two angles are also equal. Now, since all the three angles are equal, both these triangles are similar to each other. So these two triangles are similar. For two similar triangles, we can write down the ratio of their proportional sides. So how do we write down the ratio of the proportional side? We consider the side opposite to the equal angles. So side opposite to angle CAB in case of the bigger triangle will be A. So A upon side opposite to angle ADB in the smaller triangle ADB, it is C. So A upon C. Then we'll take this angle ACB and angle DAB. Side opposite to angle ACB in the bigger triangle is C. So we'll have C over here, and side opposite to angle DAB in case of the smaller triangle is P. So from here we'll get a relation C square is equal to A into P. Similarly, if we consider the second pair of triangles, right angle triangle, let's say the original triangle ABC and the smallest triangle ADC. If we consider these two triangles, we can prove that these two triangles are also similar. Say, as we can see, angle CAB and angle ADC are equal to 90 degree. So these two angles are equal. Angle CAB is equal to angle CDA, and both are equal to 90 degrees. Okay. Next, if we see angle ACB and angle ACD are common to both the triangles, so this will be also equal as they are common angles. ACB is equal to angle ACD because they are common angles. So if two angles are equal, the third angle will also be equal. So the third angle in case of the bigger triangle is ABC, and in case of the smaller triangle it is CAD. So angle ABC is equal to angle CAD. These two angles will also be equal. So if all the three angles are equal, these two triangles you can say are similar to each other. So these two triangles are similar. Now for two similar triangles, we can again take the ratio of the proportional sides. So in this case, let me write it down over here. So side opposite to the equal angles will be proportional. So for angle CAB, the side opposite to it is A, and for angle CDA, the side opposite to is B. So we'll get the ratio A by B is equal to, and for the next pair of angles, side opposite to angle ABC, side opposite to angle ABC is B, and side opposite to angle CAD is Q. So we'll have the ratio B by Q. So from here we will get B square is equal to A into Q. So this is the second relation that we have arrived. Now let us consider the third pair of triangles, that is two of the smaller triangles, triangle ADC and triangle ADB. So triangle ADC and triangle ADB. In this triangle, let us first of all consider this angle as theta. So if this angle is theta and this entire angle is 90 degree, so this angle will be 90 minus theta. Now in this triangle ADC, this angle is 90, this angle is 90 minus theta, so this angle will be theta. Similarly, in triangle ADB, this angle is 90, this is theta, so just this portion will be 90 minus theta. If we see in triangle ADC and triangle ADB, we find that angle CAD is equal to angle ABD, since both are equal to theta. So angle CAD is equal to angle ABD, since both are equal to theta. Similarly, angle ACD will be equal to angle DAB, and both are equal to 90 minus theta. And finally, angle CDA is same as angle ADB, since both are equal to 90 degree. Hence, all the three angles are equal. We can say that these two triangles are also similar to each other. So from the ratio of proportional sides for a similar triangles, we'll get the following ratios. Side opposite to angle CAD, side opposite to angle CAD is Q. So we'll get Q upon side opposite to angle ABD, which is, let's say, AD. Okay. From the second pair of equal angles, side opposite to angle ACD is 90 minus T. From the second pair of equal angles, we'll get side opposite to the angle ACD is again AD. This will get AD upon side opposite to angle DAB. DAB is P. So we'll get P. From here we'll get the relation AD square is equals to P into Q. So these are the three important formulas which will be very helpful in solving your problems. Okay. Please remember these formulas with the help of a diagram. It is important for you to understand how these formulas are derived, because if you simply mug up the formulas, you will definitely going to mess up the values. So it is better if you understand the concept, how these formulas are derived. So it will be easier for you to remember them. So this is all about triangles. In the second part of this video, we will discuss in detail about quadrilaterals and circles. Thank you.